Hello there everyone, you've tuned in UXW Bill once again. The video that you're about to see, well, some of you probably saw it coming from a mile or at least a few months away. As you may remember, a couple of months ago I made a video discussing the repair of this RadioShack digital multimeter catalog number 22-811, and I expressed my sincere disappointment at the time that I had to effect such a repair against a test instrument, because a test instrument such as a multimeter is one of those things that you come to depend upon even if you're a fairly lightweight electronics hobbyist. And if you seriously depend on one of these things for your livelihood, it just can't fail you. And unfortunately, this thing has once again. First of all, let me demonstrate the second most severe failure of this particular unit. That's right. There is no stand on it. None whatsoever. And its base is rounded. So it will never stand up. And it will in fact inflict abuse upon helpless Model M keyboards everywhere if you continue to allow it to do so. But I am not going to do that. This multimeter's first and most severe failing, and the reason why I am retiring it, has to do with the test lead situation. The test lead contact point arrangement on this multimeter is hopelessly hokey, so bad in fact that I almost returned it not long after I bought it, but I figured at the time, being the eternal optimist that I am, you know, it can't possibly get much worse than it already is. Well, it has gotten worse to the point where I'm not even going to bother repairing it anymore. In the previous video I made discussing this meter's repair, I demonstrated how the common probe terminals inside the body of the meter had actually pulled out of their solder joints and broken free, resulting in this thing making highly erratic and unreliable measurements. I put them back in there. I thought they might stay if I was careful with it, but they haven't. All I managed to do was buy myself some time. I guess I shouldn't be so hard on this thing though, because date codes inside it pin its manufacture to sometime around the middle of 2010, and I probably bought this at the end of 2010 or early 2011, somewhere in there, and during that time it has endured a lot of use. You can probably tell from the level of scuffing and scratching on the display window that this thing has not always had the easiest life. So maybe I'm being a little tougher on it than I should be. I also happen to discover that it does something very cool if you hold down any of these 4 function buttons. You see, I was just playing around with this thing after it had broken, because at that point I really didn't care if I managed to break it in some clever manner by tinkering around with its internals. What I've discovered is that when you hold down any of these 4 buttons, apparently that enables some sort of a display self-test mode when you turn the meter's power on and select any of the available testing ranges. Well, that's the rest of my day planned out for me. I'll see you all later. Thank you for watching this video, and feel free to leave a comment if you happen to have one. Okay, you can all breathe easy now. I was just kidding about that. Although I am very easily amused and fascinated by the contents of liquid crystal, LED style, and vacuum fluorescent displays, I am certainly not going to spend the rest of my day staring into a multimeter locked on its test pattern or until the battery runs down. Without that multimeter, I was left in a bit of a pinch, because even though I have a few multimeters kicking around, well, none of them are very high quality, and none of them are in very good shape, and some of them don't have any test leads, some of them don't have any batteries, and some of them, like this one, are just barely worth having. You've probably seen one of these things before. They are sold the world over, and they are exceptionally cheap, to say the least. This is a digital multimeter in the broadest sense of the term, in that a dandelion is pretty much the same thing as a oak tree. But these really are not very, very good. I would imagine they're more than enough if all you are is a very lightweight user of a multimeter, and it has to be said again, they are amazingly cheap. I can't even imagine, considering even the labor situation in countries like China where people work for pennies a day, how they can make these things as cheaply as they can. But this is the kind of multimeter that here in the United States you can buy for $5, if not less than that, with a battery included. And places like Harbor Freight Tools, they actually sometimes give these things away. Rather remarkably, these do actually work, but they are absolutely useless for any halfway serious amount of electronics work. They're great for testing batteries. If you're really feeling like a daredevil, you can test your household power with these things, but There's really no meaningful safety certifications printed on here, no CE, no UL, CSA, TUV, anything along those lines to prove that this thing would actually behave in a safe way if all hell cut loose, or its ratings were heavily exceeded, or it was being abused or incorrectly operated by the person who happened to be holding the probes. These things are also particularly useless at the lower end of their resistance range, as I found out while I was poking around with some low-value resistors. Below 2 or 3 ohms, these things just lose all shade of accuracy. So not really very good at all, but definitely enough to get me out of a pinch until I could go buy something better. And speaking of Harbor Freight, this is the model I bought. The name will probably look familiar to those of you here in the United States, maybe Canada as well. I don't know if Harbor Freight Tools has any presence there. This is the Cen-Tech item number 98674, 14-function professional digital multimeter. In addition to all of the multimeter-y functions that it has a number of other interesting functions as well. 2 of them are pointed out here in fairly bold print on the box. We have a mention of sound level luminosity. However, there are other functions on this unit that are not mentioned so prominently on the front of the box. There is a temperature sensor that utilizes an external thermocouple or a sensor internal to the meter. Likewise, there is also a humidity sensor, so this meter does it all. And occasionally you can find these on sale for around $40. Unfortunately, since I had an immediate need, I did not have the virtue of waiting for a sale, and I paid the full retail price of around $56 or $57, somewhere in there. Of course, when you go to Harbor Freight Tools, you don't always know that you're getting something that's even remotely suitable for the task you have in mind, which has certainly led to some people referring to them, not entirely unjustifiably so, as hazard-fraught tools. Fortunately, I don't think that is the case with this particular multimeter. It is actually made by a reasonably well-respected company known as Mastech. Mastech is the original equipment manufacturer for a lot of private label meters. I don't know whose all products they make, but just like the X-Tech company has manufactured or at least designed some of RadioShack's meters, Mastech makes them for a lot of other people. And many of those meters are perfectly serviceable. But I suspect that my decision will have its critics, some of them perhaps quite vocal in the comments section. I will try to address 2 of the main points of criticism that I foresee. And as proof that my crystal ball is eternally out for service, I will probably get a million other forms of criticism about this purchase that I never saw coming from a mile away, unlike the failure of the common probe connector in my RadioShack multimeter. First of all, no, this is not a fluke multimeter. And I know it's not. I knew very well what I was buying when I bought this. As nice as it would be to have a fluke multimeter and know that decades from now I would still have it, it would probably still work just fine, the price to entry is very, very high. And I know there's a saying about, you buy the cheap tools a dozen times or you buy the good ones once. I don't think this situation is anywhere near that dire. I think this will be an entirely serviceable and hopefully reliable multimeter. Time will tell. And if something does happen down the line, I will certainly produce an updated video if I feel that the reason for doing so is exciting enough. The other problem that this multimeter has, and for which some people will really pan it, it is not a true RMS AC multimeter. That is to say, if you are measuring an alternating current signal that is not a true sine wave, this thing is only taking averaging measurements, and that can lead to your being misled about what an alternating current circuit is doing at any particular point in time if it is not emitting a true sine wave, like, say, a cheap inverter would not do. Most UPS systems for consumer grade use, they don't output true sine waves when they're running on battery power either, and that means this meter would be relatively unsuitable for working with those sorts of things. But if I need a true RMS multimeter for taking AC measurements of sources that do not have true sine wave output, I have one. That is not a problem. Different horses for different courses. I can simply switch to what's appropriate. So now that we've talked about some of the potential criticisms that I could face for having purchased this, let's go ahead and talk about a third one, and that is the potential for a machine that does multiple tasks to do none of them particularly well. I don't know how that will pan out, but I have an idea a little bit later for finding out. So let's go ahead and take a closer look at the box. You can pause the video to read any of this that you would like to know more about. can see the probes and the thermocouple there. When you are looking at the box, if you are of a mindset to do so, see if you can spot the mistake that was made on this box. And I will give you a hint. No, it is not any kind of particularly egregious English or anything along those lines. It's actually quite subtle. Here's a look at the back, detailing some of the features of the meter. Some of its ergonomic features, the number of counts that it has, automatic zero adjustment. If you look closely at the LCD panel on this meter, they'll tell you that it is a 5-in-1 model. Again, they sell its capability short, because I think even with just the multimeter functions considered and paired alongside the humidity, temperature, light, and sound measurement, that you probably end up with a lot more than 5 things that this meter can do. Of course, I never was anybody's idea of a math student, so I'm probably wrong, and if I am, I hope you won't laugh too hard. There's the barcode. Made in China, of course. You would expect that. Because of continuing improvements, actual product may differ slightly from photo, and then Harbor Freight Tools address. So let's go ahead and open the box here, see what we actually get. The Mastech version of this multimeter comes with a nice case. Unfortunately, the hazard fraught ones do not. It would be nice if they did. But let's see what we do get. We get the meter itself, and those of you who are deeply familiar with this will realize that I have already had this box open, but I made an effort to put everything back exactly the way I found it, so it would be reasonably true to what it would look like if you actually bought one of these. Blessings be heard, this multimeter has a stand. That is just absolutely wonderful. After having lived for so many years without one, well, I'm glad to see that this one does qualify. I would not have purchased it if this multimeter did not have a stand, because I have learned my lesson about doing things like that. Excuse me. So here's the meter itself. The quality looks pretty passable. Looks to be reasonably well made. It's certainly not going to be as well made as something like a Fluke. I don't know if that's some kind of a date code. 17th day of 2015, 17th week. There certainly aren't 17 months in 2015. If there is, and your multimeter has a date function, well, it's had a very bad day. We do have a certification marking here on the front, a CE symbol, which means more to our European residents than it does to anyone here in the United States or Canada. Also a double insulated symbol. I don't see any evidence of a UL listing on this, but that's probably okay. UL listing is, I think, more stringent of a process than CE certification, but if that mark is real, and I would assume that it is genuine, well, it probably means that this thing is certainly safe enough. Again, if you buy a more expensive multimeter, you do get better safety, higher safety class ratings, category ratings, higher voltages that can be safely measured, better protections against severe cases of misuse or mistaken operation. I wouldn't use this thing in an industrial setting. I don't think that would be a very good idea. But around the house, and even for fairly heavy-duty electronics hobbyist use, I think it's likely to be perfectly fine. Speaking of safety-related items, we have a set of multimeter probes here. These look pretty well made. The wires actually do have some identifying marks printed on them, and some safety claims. Again, I don't know how true any of these are, but you can see that there is a category 3 marking on there for allegedly 1,000 volts worth of measurement. I'm not sure it would be a good idea to actually measure 1,000 volts of anything, AC or DC, with this particular multimeter. And here you can see the actual OEM of this particular multimeter is readily confirmed. It says Mastech right on the test probes, so we know that they are the actual maker. A couple of the product reviews on the Harbor Freight website also serve to confirm that. Now, there's a lot of functionality present in this particular meter, and that includes some undocumented features as well. The chip that this meter bases on has the ability to communicate with a computer for data logging purposes over USB, but neither Mastech nor Harbor Freight sell a version of this multimeter with that capability implemented. But some clever people online figured out how to get the chip to talk to the outside world, how to isolate it appropriately so that you wouldn't expose your computer to hazardous situations, and they have actually written some software to talk to it as well. So if you want to go that route and you're not afraid of invalidating your warranty on this, which only runs to 90 days, although they will try to upsell you a service contract on this, well, you can certainly do that. Got a nice clear looking liquid crystal display window, no scratches or scuffs or scars just yet. A series of buttons, relative measurements, range if you decide or need to defeat the auto ranging, a select function that probably serves to choose between functions on the main dial down here that have multiple purposes, such as the Hertz and duty cycle, degrees Celsius, degrees Fahrenheit, a hold button. This has a bit of an unfortunate design decision because it's doubled up with the backlighting button, and the backlighting is only on, I think, for about 10 seconds on this, and then an option to choose between Hertz and duty cycle. I really should read the manual for this. I did earlier, but I have slept since then, and my memory is fuzzy. On the top of the multimeter, we have the relative humidity and temperature sensor that's built in. We have a light sensor with a frosted plastic shield over it, probably to help it better average out the readings that it receives, give it maybe a little bit of hysteresis so that it doesn't jump all over the place like crazy. And then we have a picture of a trumpet, which is certainly an unusual thing to find on a multimeter, but in this case I believe it indicates the presence of a microphone being behind those 6 punched holes with a 7th in the center. So, alright. I'll go ahead and take the caps out of the test leads here, set those aside for safety purposes. The test lead connections on this meter do appear to be better made than the ones on my RadioShack meter, and that was definitely something I was looking for when I bought this particular unit. You may have noticed the clear plastic around these. That does have a purpose, which I will get to later. And in order to get to it, we have to continue our exploration. Here is the multimeter's little thermocouple. Probably not the most durable thing, and certainly not the most advanced technology concept here, but certainly serviceable for quite a few measurements, which we might try just a little bit later in the video. And then, for those of you who have been wondering about where the mistake on the packaging was, it's right here. What do these look like to you? They look like pretty cheap and cheesy batteries to me, but they are batteries when it says there are none. So, bonus! Go ahead and open these batteries up. Could use one of the meter test leads to do this, you know, get around to abusing my tools right away. I'm sure that'll provoke some interesting comments. And for safety purposes, you do have to unscrew the back of this multimeter so that you can get... Using screwdrivers of the proper size is really overrated, you know that? Going upstairs and getting the right tools to do the job, pish-tosh. Who ever heard of that? But you go ahead and you undo these screws. And for those of you who are wondering, the green skin does not come off the outside of this multimeter. Okay, I have returned after a momentary interruption, thanks to the magic of video editing. I've gone ahead and installed these super cheap and cheesy Tinco batteries. These people actually do have a website. I was amazed by that fact. They're just carbon zinc super heavy duty formulation batteries, so I doubt they're going to last all that long in a multimeter such as this. But hey, free batteries, better than nothing, especially if you run around the house like a ninny trying to find batteries and only discover that everyone has hidden them from you. Down here we have a protective fuse for the multimeter, a very welcome feature to see. Something that even this little red cheapie does happen to have. And the back panel text on it would even seem to insinuate that it's replaceable. But I guess at some point these things have gotten even cheaper than they already were because the fuse is actually soldered in place on the board and it's not a conventional AGC style glass tube fuse. This is actually a ceramic fuse. Had some people ask about that in the previous video about the RadioShack meter. And the reason the fuse is ceramic is to lessen the likelihood that it would explode, which already ought to be pretty low risk unless you are seriously abusing or overworking this multimeter. But it's certainly a possibility. I seem to have had... Nope, there it is. One of the screws tried to take a vacation without leaving Walsh Motors, but didn't get it done. It should not be much of an issue for a serious explosion to occur unless you were doing something that was well outside of the published guidelines of this multimeter, or it turned out to be a complete piece of junk, which again, I don't think that it will. Still haven't taken the opportunity to go and get the right screwdriver. I'm sure I'm going to get a bunch of lovely flames in the comments for that. especially since this is a brand new multimeter. While we're talking about things with fuses and screws, I will briefly revisit the RadioShack multimeter, because I did have a suggestion from someone in the viewing audience. I think that one's going in cross-threaded. That's never good for it. Try that again. Yeah, that one does not want to go in properly. I can hear some wise guy in the chat going, "That's what she said." We'll be back in just a second, thanks to the magic of video editing. Okay, so I'm back, and as I said, the RadioShack multimeter is going to get one last shot at being in the limelight, because it does still work. It's just that the test lead configuration is all messed up. At least one person suggested in the video I made documenting the repair of this unit that if it broke down, one way that I could potentially effect a repair would be to simply solder a wire directly to the stricken negative or common terminal on the unit. But that's not really a very safe thing to do, even though if I do something right now with this particular alligator clip, which is a dangerous kind of thing that you absolutely never should do. Do not do this. UXW Bill is a professional bad example operating on a closed course. Do not try this at home, and especially do not do it on a video when you're not sure that all the ancillary devices that you need are readily to hand. But if I go ahead and make a connection directly to the common terminal on this meter, and I get something like this little sealed lead acid battery from PowerSonic, go ahead and hook this up. Take the old meter lead here and make a measurement. You can see that this meter does still function, but like I say, that's an extraordinarily dangerous thing to do, especially if you ever plan to do anything with AC power line connected stuff or other high voltage, high current, or any combination thereof circuitry. It wouldn't be a good idea if something were to go bang, especially with this multimeter all taken apart the way it is. So it is going to be completely retired from use. Who knows, I might decide to stick a set of permanently attached leads on it and use it as a battery tester or something along those lines, because I really hate to throw away anything that still works to any capacity as long as there's something I can do that's relatively safe with it. And extending on the concept of safety, there is a feature present on this particular multimeter that's really, really nice. If you're new to the use of a multimeter and you have no idea what you're doing, or you're not always sure where you should hook up the test probes, and this will explain the clear jackets around these input connections. When you turn the meter on, you'll see that the input connections on it actually light up to show you where you should plug in your test leads. Now, many of the tests that you can run use only these two connectors, the common and the volt, ohms, and hertz, capacitor and diode test connection, but a few of them, such as the microamps and milliamps test, or the temperature probe, they use this connection. The higher amps range, the only thing that uses this connection right here. And then you go over to the other way, and if you choose some of these functions like the sound meter, or the light meter, or the higher light meter scale, or the temperature scale, you end up with none of these plugins illuminated. That's not to say that you have to disconnect the cables from them in those ranges, but it might not be a bad idea. So let's go ahead and hook up our test leads to the meter. They seem to make very positive contact, something that the RadioShack meter's test leads never did. And of course I have misplaced the negative one like a boss, but it's here now. Go ahead and plug these in because I'm very curious if they still light up when the test leads are plugged in. And the answer is they do not, which is just as well because you really couldn't actually see them. And then of course there are these insulating tips on the test leads to protect them and protect you from jamming them into yourself. If you are doing some kind of electronics testing work, it's a very good idea to insulate all but say the last tiniest little bit of the probes on your multimeter so that an accidental probe slip is less likely to introduce a short circuit that later produces costly damage. I have seen some multimeters that come with little jackets that serve to shorten the test probe's effective conductive range down to just the bare minimum here. You can see these actually do have little indentations on them where you can use that to get a grip against the components that you're testing. We're on the voltage scale right now. It is in the DC volts testing range. You do have to choose between AC and DC testing on this multimeter, although it will determine the voltage range in which you are testing automatically unless overridden. It will not determine the type of current that you are testing. So you have to be very sure that you choose that properly. Otherwise, you could be led to believe that a circuit is not carrying any electricity when it is. So here we have this battery again. And I've gone ahead and connected the leads to it, and at least out of the gate this meter seems pretty passably accurate on the voltage range, but we're not really doing anything that would severely test it here. Nope, the tests come later. And for those of you who are looking at this multimeter review video and saying, hey, I think I want to buy one of those, but I've really got to know beyond any question of a doubt how precisely it is capable of measuring and how accurate it is, I'm going to tell you right now, this is probably not the video you want to watch, because although I have a great many electronic doodads and gewgaws along the way, I do not have any particular high precision sets of devices to test a multimeter against, like a precision resistance tester or a diode test or anything along those lines to verify that this thing is accurate down to the last little bit. I do, however, have some good news. If you buy one of these meters and you find that it is inaccurate, and you do have accurate references by which to try and reset it if you don't want to return it to the store from which you purchased it outright, you can certainly do that, because the calibration procedure and service manual for this particular multimeter from Mastech are available online. People have asked and received them. Apparently Mastech is not one of those companies that just ignores all their customers as soon as they've bought the products, or refuses to grant access to service information based on the rather faulty concept that the only thing consumers are going to do with it is to end up hurting themselves along the way. So if you find that you need that information, it is certainly available, and that is another major point in this multimeter's favor. If ever you have to be sure that it is calibrated correctly, or you want to know how to do it and you are suitably equipped to do so, that information actually does exist. The first thing we'll do in greater detail is a voltage test, and for that particularly exciting category, I have the following very interesting item just a little bit further over here on the workbench. This is an inexpensive 5 amp capacity, 0 to 30 volt regulated benchtop power supply. It is, as you would expect, an inexpensive Chinese produced unit, but it is easily one of the best purchases I have ever made in the course of pursuing my electronics hobby. Everyone should have one of these things. The only trouble this thing has ever given me, other than I suspect it might not live too long if you were asking it to work against its current limit for very long, is a little bit of a flaky solder joint here in the voltage display on this particular side of the unit. But for the most part, it does everything you could ask. And what I'm going to do here is hook up the multimeter and run through the voltage range on this, making a couple of stops along the way to see just how close it is. I don't know how close this thing is, but I would assume it's pretty accurate. When I did this test with the RadioShack meter, the RadioShack meter always read just a few tenths or hundredths of a volt high, depending upon where it was in its range. It seems that some of my other multimeters, such as this little cheapie right here, are about the same way. There's just a little bit of difference between this thing's built-in metering of unknown accuracy and what the other meters do. So let me go ahead and get the test leads hooked up here, verify that they are indeed correctly hooked up, and I will be right back. Alright, once again I have returned. I have the variable regulated DC power supply hooked up to the Cen-Tech 98674 multimeter. And we're sitting at just shy of 1 volt right now. We'll go ahead and use the fine voltage adjustment here to bring the voltage up to 1 volt even. And you can see that although it took us a while to reach the 1 volt mark over here, the meter is a little bit ahead of us, but certainly not anything to worry about, and I would assume that it is well within its specification. It's certainly no worse than any other meter I've had. And again, a much higher end meter than this one might do a better job, but this does appear to be pretty stable. You can actually try changing the range here, seeing just what kind of precision it will give me. It looks like it's too high for the millivolt scale already, which usually goes to around 2 volts DC, but in the case of this meter it does not. Let's go ahead and see if we can turn on the backlight. The backlight is probably incredibly hard on the battery, but it is very bright and very readable. And this display actually seems to have a pretty good viewing angle. The camera tends to wash out prematurely. It looks like we're no longer making electrical contact here. So we'll try to get back to that. And then we'll bring up the voltage to that of the common AAA, AA, C cell, and D cell battery. And again, the meter's reading a little bit high, but not terribly so. And I don't know for sure how accurate this regulated power supply is, but in general, a couple of tenths or hundredths of a volt are not going to make any difference in all but the most critical circuits. And people like me just generally aren't doing that kind of work. See if we can get to 3.4, 3.3 volts. It seems the margin by which it's off is actually staying pretty constant. We'll go up to a little bit higher. Go up to about 8 volts DC. And of course I've got it out of the automatic ranging, so we'll put it back in auto ranging mode. Make sure we're actually making good contact here, which seems to be a little bit of a challenge. Seems to be getting closer in terms of accuracy. Alright, we'll go ahead and bring this up a little further. Somewhere around the territory of a fully charged lead-acid battery, like you'd find in a car or something along those lines. A lead-acid battery that's actually being actively charged. There we are at the 20 volt mark, and again it's a few counts out, but not bad. And then we'll just give this thing everything it's got. It tops out a little bit above 32 volts, 32.3 by its indication, 32.19 by the multimeter's indication. Now let's take a look at some resistors. I don't have a whole lot of resistors around for testing purposes, but let's go ahead and see what I can come up with. First off, in the range of various continuity-related tests is the audible tone-related test that detects either very low resistances or total short circuits. If I go ahead and connect the meter leads, you can see that it does indeed produce a tone. You can hear it more than see it. One thing to notice about this is that it becomes rather scratchy if I move the test probes around, which suggests that there's no sort of hysteresis, which is a quality of something to stay in the current state that it's in, to be minorly to moderately resistant to small changes that aren't really of significance to what we're doing at any particular point. There's also no sort of latching to hold this thing into the state that it's in. So the continuity testing is serviceable, might not be the best, but it should certainly work well for most people, and I think that the lack of any hysteresis or latching in its tone production might serve to better indicate where there's a marginal connection. I view it as a better feature as opposed to a drawback, but certainly some may differ. Now for the resistance test. What you're looking at right now is the printed circuit board out of a derelict StatPower Portawatts 300 series inverter. If you really want to know, it's got some shorted FETs on the output, blows fuses whenever you plug it in, and I'm just kind of gradually stripping parts off of it because the construction quality is so incredibly poor. I don't know how this thing managed to last me from the late 1990s until about 2012 or so. But there is a very nice little low value, pretty precise 5% tolerance resistor here on the board that we can go ahead and test. It is a 0.1 ohm resistor, and unfortunately here our Mastech multimeter seems to be turning in a bit of an unfortunate result. But giving it time to settle down, it has gotten close to the right value a time or two, and it is certainly possible that other circuitry inside this inverter is interfering with the accuracy of its resistance test. So at the low end, I'm not really sure that this goes low enough to meet my needs, but it does seem to work. It's certainly a million times better than what this thing had to say, which was way, way off. Like I said, these little cheap meters, they are useless for high precision measurements. Other resistors in here of much higher value, it would certainly do much better on. So it's close, but depending upon your outlook, you might say that close only counts in hand grenades and horseshoes. And you might not be far wrong. We'll go ahead and take a look at some other resistance checks. Our next resistor contestant on The Price is Right is a 51K ohm resistor, again with a 5% tolerance. This one's a little hard to get at, but that's not too far off. Again, in the least significant digit, it's a few counts out, but it's not terrible. Certainly well within the tolerance of the resistor itself at 51.3 reported K ohms of resistance. So the resistance testing range is a little off at lower end and might not be stable enough at the lower extremes of its capability. But again, it's probably good enough for most hobbyists, and we'll see how I get along with it over time. This is just a quick look at the diode testing function on this particular meter, showing the voltage drop across an extremely boring 1N4007 series diode. I don't have any really fancy-dancy diodes to put this thing through its paces. In fact, the only reason I knew I had a 1N4007 was the fact that it was sitting on the nightstand next to my bed. And before you start looking at me like that and saying, "What? Doesn't everyone keep a bunch of diodes on the nightstand next to their bed, or at least one?" Well, I certainly do. Here is a capacitor under test using the capacitor testing auto-ranging function of this particular multimeter. The capacitor under test is a 400 volt, 22 microfarad capacitor, and once again the displayed measurement is pretty close. I would imagine that it is certainly well within the tolerances of the capacitor, which is nothing very exciting. It's just a pretty standard power supply filtering electrolytic for a very small application. It actually came from a dead APC backups if you're really curious about it. We'll go ahead and grab some other capacitors here and see how it does with those. I don't remember what this unit's exact capacitor capacity testing limit is, but I do know that the notation is made in the operator's manual that larger capacitance values may take several seconds to test while this multimeter charges them up. The operator's manual for this multimeter tells us that it can test a maximum of a 100 microfarad capacitor. I've got one hooked up to it right now. Let's go ahead and see if it's actually managing to do so. As you can see, it's certainly taking a while to make up its mind. And I would say at this point that it has probably failed that test because it is reporting that it is over the limit when the specifications within the manual clearly say that 100 microfarads should be within its testing capability. I'll give it a couple more seconds and we'll see if it's going to do anything here, but I think we're probably out of luck. And I don't know if you can manually specify a testing range in the capacitance check or not. It seems to ignore my depressing the range button, so I am guessing that it cannot be used in that fashion. In an effort to try and better figure out the upper limit of this thing's capacitance measurement, I've gone ahead and placed two capacitors in parallel with one another, both of them 22 microfarad units rated for 50 volts apiece, and as you can see, the multimeter has managed to successfully test them and is reporting about a 45.6 microfarad capacitance reading. So that's certainly good enough in my book. I'll go ahead and throw in another one here, and we'll just see if it can actually manage to take a reading off of that. Here now are three capacitors in parallel with one another, which at 22 microfarads apiece should result in around 66 microfarads worth of capacitance, give or take a little bit of shipping and gouging along the way. And again, the multimeter is pretty close, reporting 68.9 microfarads worth of capacitance. Now, something that should certainly be considered here is my somewhat hokey configuration of test leads. In order to make it possible for me to operate the camcorder, I have got a set of alligator clip leads that are somewhere around a foot long attached to the meter's own leads. And test leads and various other wiring connections have capacitance of their own that could certainly serve to throw the reading off a little bit. But we are certainly well within the tolerance of things here. Let's go ahead and put another capacitor in the bunch and see if this thing's reading can scale up to that increased level of capacitance, or if that's where it hits the ceiling. I don't know about you, but I certainly think that my capacitance testing arrangement here is starting to look like a contraption. The lead length of the capacitors is definitely fast becoming an issue, and it's a wonder they haven't shorted out yet. But over here on the receiving end, it would certainly appear that the multimeter is still in the game, reporting 92.3 microfarads of capacitance. Again, that is certainly very close to what we have over there with that test lead arrangement. So why it couldn't manage a 100 microfarad test, I don't know, unless maybe the tolerance of the 100 microfarad capacitor I happened to pick was a little bit on the high side and this thing's test is really that tightly limited. It certainly could be. Now, a real proper external capacitor checker is what anyone who's halfway serious about testing capacitors should certainly have to hand. But this thing will certainly do the job when it comes to a lot of motor starting and running capacitors, like those that you find in an air conditioning or fan motor or any other kind of permanent split capacitor motor setup. Of course, it does have to be said that there is another caveat here that anyone using this meter should be mindful of, or in fact any meter, and that is the fact that this thing does not test anywhere near to a capacitor's working maximum voltage rating. So it is entirely possible that a capacitor could go flaky when it is exposed to the stresses of a normally operating circuit that pushes the capacitor potentially up to its working voltage limits. And that is a defect that a multimeter like this or any other that does not test under the full rated capacitor voltage cannot find for you. And now for what might hopefully be a little bit better of a shot at accuracy, or at least my making any effort whatsoever to tightly control the parameters against which this particular multimeter is going to be verified. What you're looking at right here is an American Power Conversion remote temperature and humidity probe that is connected to an AP9618U management card in a smart UPS 1500 uninterruptible power supply. One would certainly hope that for what these probes and management cards and uninterruptible power supplies cost, that American Power Conversion and Schneider Electric took great pains to make them accurate, to a very high degree. I guess we'll find out. The screen that you're looking at right now is the built-in web management interface of the AP9618U APC remote management card. And while the temperature sensor itself is identified as an internal sensor, as you just saw, it is most definitely external to the UPS with a cord length of around 10 feet or so. This particular sensor is reporting a temperature of 75 degrees Fahrenheit and a humidity reading of 53% relative humidity. Those humidity numbers might seem high, but consider for a moment that I am here in the basement, and although you can definitely hear a dehumidifier running in the background at this particular juncture, it has not been running for more than approximately a half an hour or so. Now let's go ahead and see what the multimeter's opinion of the temperature and humidity down here happen to be. The multimeter differs by a little bit. It reports 57% relative humidity and about 1 3/4 degrees higher than the APC management card does. But again, I would imagine that is well within reasonable margin of error. It also has to be said that during the course of this video, I have been handling this multimeter and could have certainly influenced its temperature reading by virtue of my body heat. One very nice thing that I have noticed is that in all of its varying test ranges, this multimeter continues to report the temperature and relative humidity. And I strongly suspicion that you could use a reading like this to do any necessary temperature compensations on the components that you might be measuring at any particular given time. I'm also very pleased to hear that alarm sound that's going off right now, because I just switched the testing range over to the milliamp microamp setting, and the probes are not presently correctly attached. Some multimeters will let you do this with potentially explosive or disastrous consequences, and they won't make a single peep. But this one, I'm happy to say, sounds a very noticeable alarm, and certainly no one should be able to ignore that blinking light. And just to be thorough, the same alarm is sounded if you switch with the meter configured for its current measuring range to one of the voltage or resistance measurement ranges. The alarm again sounds, and the correct connection for the positive probe of the meter is once again seen to be flashing. So it should be very hard to screw up and kill your multimeter. Here are the results of a quick check of my AC line voltage here in the house. And once again, these numbers compare pretty favorably to those of the APC Smart UPS 9618U management card, which in my opinion has always measured its voltage a little bit on the high side. But let's go ahead and have a look at it for cross comparison. Here's what the APC Smart UPS and its management card have to say about the input voltage. It registers just a little bit higher at 121.6, and certainly some of the difference here can be explained by the fact that both of these measurement points are being taken from different circuits in my house, and they also have a differing distance leading back to the ultimate outlet that they are being sourced from. So in addition to variances in test instruments, it also has to be considered that there are slight differences in voltage drop. So again, the multimeter is certainly doing an extremely credible job by comparison to a much more sophisticated and expensive and hopefully better calibrated instrument than itself. And now here's a demonstration of one of the key drawbacks of a meter like this that does not feature true RMS AC measurement capability. Plugged into a very cheap and nasty 200 watt power inverter that is being run from my benchtop regulated power supply over here is a P3 International kilowatt measuring device. Very nice little device. If you don't have one of these or something like it, you should buy one, and you should buy one yesterday. They are great. And as you can see, the kilowatt by necessity is capable of performing true RMS measurements and thus gets the output voltage of the inverter pretty much correct. The inverter in this case is utilizing what is referred to by marketers as a stepped approximation to a sine wave. There is really nothing at all sine wavy about its output. In fact, it looks very nasty when viewed upon a scope. You will see that it is nothing more than a square wave with periodic steps to a zero level. Still, a lot of equipment will run acceptably well from such a power source. But the little Harbor Freight meter over here does not get the voltage right because it is only performing an averaging measurement. And thus, if you were trying to perform tests upon such a piece of equipment to verify that it was working correctly, you could be led to some very misleading conclusions. It is really rather surprising that a high-end, well, I won't say high-end because it's certainly not, but a firmly middle-of-the-road multimeter such as this at a far above the bargain basement price range does not perform true RMS AC measurements, and that is definitely a mark against it. This is just a quick look at the frequency testing range. I presently have the test probes plugged into an AC power line attached outlet, and just like the kilowatt meter that I showed previously, this thing indicates a frequency of 59.9 cycles per second or hertz on my AC power line. So again, it may not be 100% accurate, but in my book it is certainly more than close enough. And just as a reference, the kilowatt, although it is a mass-produced testing instrument and a rather low-cost device, it too does appear to be calibrated very closely to 100% correct, at least when they come down the assembly line. Mine has been through quite a few things since then, has managed to lose its ground pin over time, but in general I would say it is certainly still accurate enough for regular measurements that don't demand a great deal of precision. Here's a little bit of an expansion on some of this Harbor Freight Cen-Tech 98674 multimeter's frequency measurement capabilities. We saw just moments ago that it's perfectly capable of picking up the AC power line frequency, but upon looking at the owner's manual I discovered something that gave me a bit of a pause, and again seemed like it might be a little bit less than totally wonderful and satisfactory. If we look at this table right here that explains the frequency accuracy and resolution of this particular multimeter, we see down at the bottom that on any signal greater than 200 kilohertz, the mention is made that it is for reference only, implying that it is certainly not likely to be very accurate and that it should not be used as the basis of making any adjustments. Well, in the case of my good old, recently somewhat deceased RadioShack multimeter, I can say with a great deal of certainty that it was capable of counting frequency and seemingly doing so pretty accurately all the way up to about 4 megahertz or thereabouts. And I know for a fact that it had no problem reaching in excess of 200 kilohertz because I used it to troubleshoot an AM tuner IC in a realistic tuner by probing the frequency of the IF output pin on the tuner integrated circuit, and it locked right on at 450 kilohertz. So that might be a little bit of a problem for my application, but what I'm going to go ahead and do right now is generate some waveforms on my Lenovo IdeaPad S10 netbook in Audacity. These will be at 440 Hertz, the A above middle C once again, and the first one we'll start out with is a sine wave, and the meter should certainly have no problem counting this frequency. And indeed it does not. It is pretty close to accurate. So go back once again and generate the same tone again, but this time do so with a square wave. And again, I do not expect that this should give the multimeter any trouble whatsoever, and it does not. The reading is identical. So it doesn't seem to have any trouble locking on to various different waveform types. I don't know how true that is across its entire frequency range. We might try to find out before this is over and done. Here is a sawtooth wave fed into the meter, and you can see that although the reading is a little bit high, I would certainly say that it is still well within tolerance. So let's go ahead and make a massive trip upwards. Let's go to the top of the audible frequency range, which is widely considered to be 20 kilohertz. Help if I could actually type that. Make sure I've got it right. Set it for a sine wave. Generate the tone and see what we get here. And 19.9 kilohertz is reported, so again, that's pretty close. That's certainly not bad. And we'll go all the way down. I had it plugged into the AC outlet earlier and was scoping out the 60 cycle per second frequency. Let's go ahead and see if 60 cycles per second, 60 hertz on a tone coming out of the computer registers as 59.9 or 60. And it does register as 59.9, so it's trailing by just a little bit, but I would certainly say that's well within the range of tolerance. So there are the various results of some random frequency measurements by tooling around the spectrum a little bit. And you can see that the response time for a sample isn't too bad either. I think this thing is quoted in the manual as making approximately 2 samples per second, but I could not swear to that for absolutely certain because, once again, I have slept since then. In a most scientific way, I have stuck the temperature probe for this multimeter inside the freezer after hooking it up. You will see that it is reporting a temperature of 2 degrees Fahrenheit. A nice touch is that the internal temperature sensor on the meter, as well as the relative humidity sensor, remains active at the same time as the external temperature probe. Now, there just so happens to be a thermometer in this freezer. I did have this probe stuck around the area where that internal thermometer is situated, but it seems to have gotten away. So let's go ahead and see what this thing is reading. Hopefully before I have warmed it up too much with my own body heat. It is sitting right at about 2 degrees Fahrenheit. So I would say in that regard, the multimeter is just about dead on with its external temperature probe. However, one bad thing that has been said about this multimeter's temperature probe is that if you subject it to sufficient heat, like say that of a very hot oven, it may in fact start to melt, which is certainly not a very good feature. Here the thermal probe is inside my pizza oven, which is actually set to its 350 degree or low setting. As you can see, its own thermal sensor has not gotten the message to cut the heat off. It's not that accurate, or it decides to go ahead and let things overshoot by a bit. But so far, the temperature probe itself seems to be surviving and not melting, although people who have reported its melting stated that that occurred around the 450 degree Fahrenheit mark. So I probably won't let this test go on too much longer, because I'd really rather not destroy my own example of this thermal probe. Although I guess if I did, it wouldn't be a big deal, because in theory at least, this multimeter is still under Harbor Freight's limited warranty. It does indeed look like the thermal sensor probe got a little bit warm. You can see that the wire has browned up rather nicely, but the sensor itself certainly still seems to be functional and seems to be reporting valid data to the multimeter itself. This is approximately where I had it in the pizza oven, sort of semi-secured to the rack, and back up in there behind that cage-like structure is the thermistor that the pizza oven uses to sense its own temperature. So they weren't too terribly far apart, but it's entirely plausible that one of them could have been reading a great deal cooler than the other, since it's almost at the top and outer extreme of the pizza oven's cabinet. As befits an item with very little thermal mass of its own, you can see that the temperature probe itself cools down quite quickly. The meter's temperature probe also appears to work acceptably well, more than acceptably well, in a wet environment, and again its accuracy seems to be pretty good. The temperature of the water coming out of the tap around these parts is usually in the upper 50s, lower 60s in degrees Fahrenheit. Alright, here's the part of the video where even if you think this whole thing has been a complete sham and an incredible waste of time, well, I'd hope that you could find it in your heart to at least be moderately appreciative, because this portion of the video, where I test the sound level meter in this particular multimeter, well, it took a lot of brain work, and that's not my specialty. It kind of made my head hurt a little bit. Luckily, I think I'm fine now. Here's what I've decided to do in the name of the test, and I'm just going to give headphone users a pretty fair warning. This portion of the video will get fairly loud, and I encourage you to adjust your listening volume accordingly. I'll try to give you a warning before I start up with the test, but in case I forget, this is the only warning you're going to get. Here, of course, is the multimeter set to its sound measurement mode. You can see that it's picking up the ambient level of the sound in the room. Looks like it's settling somewhere between the low 60s and 70s in terms of decibels. And then sitting right next door to it, we have my very fine, except no imitations, RadioShack analog sound level meter. Now this is a counterpart, or dare I say an analog, if you'll excuse the pun, to the digital meter of a similar type that RadioShack has sold for many, many years. But when I got to the store, they didn't have those any longer, so I settled for the analog one. It seems to work every bit as well, but it's not quite as convenient to read as a digital readout, because the first thing that you have to do is select the approximate range of loudness that you wish to measure, and then you have to use the decibel meter down here, which goes from -10 to +6, and in any given measurement range, when you hit 0 dB, that is the top end for that measurement range. Anything beyond that, and you should switch up to the next range to assure an accurate measurement. So here's what I'm going to try to do. I have in front of these meters about, probably 6 or 7 inches away, a stereophonic loudspeaker. I am, however, going to turn the balance down to monophonic, so only this channel will be playing. And I'm going to turn both of these meters on and compare their readings to one another while I try to be as quiet as possible in the room. However, I do not have a nice proper anechoic chamber or anything along those lines to do this test in a more formalized manner, so this definitely puts me at a little bit of a disadvantage. But I think we can probably hope to get close enough with a test like this. So let me move the camcorder around, and I'll be right back to do the test. Here is the setup so far. Both meters are sitting next to one another. Their microphones about equidistant from the sound source. And as you can see, they are both configured to read. So let's go ahead and do this. We'll start with a 440 Hertz tone. That is the A above middle C. and we will adjust the volume to where this meter reads 0 dB. It is set to measure 80 decibels, and we'll see how this one compares to it. So here we go. Well, I don't know about you, but that seems pretty doggone close to me. Now I'll repeat the test with a 1000 Hertz tone, and we'll see if they both remain fairly close to one another. Well, things definitely aren't quite as close there, but they're certainly not terrible. I don't know that you'd want to use either one of these instruments for a precision test, but they're certainly close enough to get you into the ballpark and to have any idea if you need to, say, start wearing ear protection immediately or something along those lines. Let's try a few more test tones and see how they behave. Okay, headphone users, consider yourself warned at this point, because the frequency tests are starting right now. We'll start in the basement at approximately 60 Hertz and work our way up to a high of 8,000 Hertz, or 8,000 cycles per second. So here we go. Alright, there is 60 cycles per second. We'll go up to the next step. And the next step. These next couple of examples may bother any pets or animals that you have in the room, so you may want to take time to get them out of there before I play these. Pause the video if that's what you want to do. I think the Mastech Harbor Freight meter has just met its match. I think the frequency response of its microphone has dropped off considerably at these higher frequencies, if it has any at all. That concludes the audio frequency and level measurement tests. So, the question that you've all been waiting for. After spending over an hour talking about this multimeter, what do I think of it? Would I still recommend purchasing it? To what audience do I think it is most relevant? I will tell you the honest truth. I think that if you are an electrical engineer or you're involved in the design of circuits, especially more precision than just hobbyist stuff, this is not the meter you're going to want. I don't think it's anywhere near accurate enough. You could probably use it if you had to. You might not like it. You might be shooting in the dark at times and have to make some blind guesses about stuff. For someone who's an electronics hobbyist, yeah, I think this meter does pretty well. Now, there's a saying about certain devices that perform a lot of functions. The more functions they attempt to perform, the less successfully they do each one of them. And, you know, that could certainly apply to a device like this. The only place in this thing's range that I worked with throughout this entire review where I felt that this thing was a letdown was in the decibel sensing range. The temperature probe seems to work well. Voltage, resistance, diode test, capacitor check, the current ratings, all that stuff seemed to do acceptably well in my book. I'd have no problem with any of that. Second in line for a slight disappointment would be the frequency counter and measurement section. My old RadioShack meter, I know it could do up to 4 megahertz because personally I tested it against the spec sheet that RadioShack provided in the manual. I'm not sure about this one. I don't have something handy that oscillates at approximately that speed to tell you for sure, so I will have to reserve comment on that at least for the time being. Another thing that I will have to reserve comment on, because I haven't really played with it very much and I don't have a good way, or at least I couldn't think of a good way to test it, is the light meter. Does the light meter do something when it's held up to a source of light? Does it do something right now if I turn it on? Well, yes, as a matter of fact, it does. Set to the lux setting underneath a 4-tube F32 T8 lamp, probably about 4.5 feet removed from it. It says that we're sitting just a hair above 300 lux, 333, 334 it ticked up to there for a second. I don't know much about that subject, so those of you who know more about lighting than I, well, perhaps you can lend your thoughts to it. Do I think this thing is worth the money? Yeah, I have to say I do. The only thing I would really do as far as improving it goes would be to offer a model with a true RMS AC voltage measuring function, because that could come in handy, and it would be nice to have one tool that can just do everything passably well. But this thing gets so very close as it is that I find it very hard to complain about anything, especially if I would have gotten it at a lower price, say $30 or $40, that it sometimes surfaces at. So in a sentence, I think this meter is suitable for a moderate electronics hobbyist. I think that someone like a proper electrical engineer probably wouldn't be very happy with it. And those are my thoughts concerning the Cen-Tech 98674 multimeter as manufactured by Mastech. Thank you as always for watching, and by all means certainly do feel free to leave a comment if you happen to have one. Uh-oh.